So the DNA, or I should say the chromosome, is a single long molecule of DNA. And it has different parts. It has a part that is pulled to the poles during the cell division, during mitosis. That's the centromere. It has genic and non-genic regions, but it's also got ends. Now, why would the ends be of any interest? I mean, one would think, well, the molecule just ends, so what? But it turns out, and interesting enough, the problem was recognized by Watson himself. When you replicate a chromosome, when you make complementary halves, which then separate from each other, you have to replicate the whole piece of DNA. But unfortunately, or for some reason that we don't understand, the enzymes, the proteins that are necessary to replicate the DNA, because DNA doesn't replicate itself. DNA is replicated by proteins, just like everything else in the cell. It's the proteins that do the work. The DNA just sits there and carries the instructions. The proteins have to do the work, and part of the work is to replicate the DNA. So to replicate a chromosome requires a protein. It's called polymerase because it makes a polymer. So it can only move in one direction. We don't know why the polymerase can only move in one direction, but when it goes to one end of a chromosome, it can just go right to the end and fall off. But since it can only go in one direction, it has no way of getting to the other end of the chromosome. So organisms have evolved a very simple, rather foolish way of doing it, actually. Before they replicate, they just extend their chromosome a little bit beyond the part that you need, and then they start where the real end is. That little piece that you put on, or that the cell puts on, is called the telomere, and that is put on by a set of molecules called telomerase, and it happens every time the cell undergoes cell division, every time the DNA molecule replicates. It has to extend the end of the chromosome a little bit so that it has a place for the polymerase to start.